Hey y'all, I wanted us to take a minute to look at special right triangles together. Just as you've done in your independent time, I would begin with the 45, 45, 90 table and have my students use Pythagorean theorem to fill in the missing blanks. Now, I wouldn't have every student do every problem. I might have certain rows or certain groups do the blue or the pink or the yellow or green so that they just kind of get a taste for what it's like to solve using Pythagorean theorem. Let's take a few minutes and look at the 45, 45, 90 chart completed. Students look at that. It's very obvious to them that the leg is always equal to the leg. The hypotenuse is always the square root of 2 times the leg. So we have used this table to prove this inductively. We see that pattern. Students get that. But why? And we also always want to ask that question, why do we have this relationship? Where does this relationship come from? And we can then take a few minutes to prove it deductively. We want our students to look at this triangle and we want them to notice that that 45, 45, 90 triangle is isosceles. So if it is isosceles, then obviously the two legs have to be equal. And we have one of our relationships right there, leg equals leg. So now we can apply Pythagorean theorem. We can let each leg be A and then solve for our hypotenuse. And as we solve for our hypotenuse, we realize the fact that C is equal to the square root of 2 times A, and therefore the hypotenuse is equal to the square root of 2 times the leg. So if we apply this same procedure to the 30, 60, 90 triangle, students are quick to notice that the long leg is the square root of 3 times the short leg, and all you got to do to get that hypotenuse is double the short leg. But once again, why? And can we prove this? We don't have a isosceles triangle this time, but we do notice that we have one shorter leg and one longer leg. The shorter leg is opposite the 30 degrees. The longer leg is opposite the 60 degrees. So if we look at that triangle, we can't really see a relationship, but if we reflect that, we see that that gives us a equilateral triangle. And if that is an equilateral triangle, then all the sides are equal. And if all the sides are equal, then C equals 2B. If we look back at our labeled 30, 60, 90 triangle, we see that that means the hypotenuse is 2 times the short leg. Now let's just focus on this triangle on the right. Once again, we know that all sides are equal. We can apply Pythagorean theorem, but we need a relationship here. And we discovered that each side was equal, so we can replace the C with 2B. Now, we have a relationship between the hypotenuse and the short leg, but we need to find some kind of relationship with the long leg. And if we notice in our purple triangle, the long leg is A. So let's try solving for A. But first, we will replace C with 2B. Now, if we solve for A, we can see that we discover that A equals the square root of 3B. If we look back at our labeled triangle, that tells us that our long leg is the square root of 3 times the short leg. So students have now seen this relationship both inductively and deductively. We also want our students to go from fluency with this to automaticity. We want them to be able to see these relationships and to very quickly solve for these relationships. And a great way to do that is using one of the Kagan cooperative learning activities. There are two, the one on the left for 45, 45, 90, the one on the right for 30, 60, 90. These, I would do them on different colors of paper and cut them up into along the dotted lines into each of the triangle. And the challenge on the mix and match is for students to all go to one side of the room and find their match. Here's a picture of some of my participants doing this last summer. I really wish you guys could get a chance to practice this, but you all go to one side of the room, you find your match. And so the person that has a leg of 2 is looking for the person with a hypotenuse of 2 square roots of 2. Once they found their match, they come to the middle of the room, I check it, and they go to the other side. The beauty of this is that as more and more students find their match, those that could be possibly struggling a little bit, there are fewer and fewer choices. The choices narrow down, and there are fewer and fewer to have to match with, and it makes it a little bit easier. And I would repeat this 2, 3, 4 times till students can very quickly find their match and go from one side of the room to the other side of the room. I do want you to note on the 30, 60, 90 activity, those triangles are not drawn to scale. And that's something that is a little bit frustrating for some of your students, but I really think it's a good idea because it helps them to focus on the 30 degree angle and the short side being corresponding, and the 60 opposite the short, even if it's not drawn that way in the picture. Another hint, and don't tell your students this, but if you notice, the matches all have the same orientation. They have the same angle labeled, and they also are going in the same direction. So you don't have to calculate this as you are checking their matches, and they think you are really, really smart. So that just gives you an overview of special right triangles, not only how to introduce those with your students, but an idea of how to practice those and help them to become efficient in being able to find the missing sides of the triangle.